Hi, I'm Alex.
And I'm Konstantin.
We're stuck at home today due to coronavirus, and a lot of people are stuck in hospitals.
And what we're hearing that especially in New York, hospitals are running short of ventilators. Ventilators are devices that help people breathe when they have a lung disease.
We decided to use our talents to everybody's best interest. I can program.
And I love to design mechanical machines, and I love to work with electronics. I'm also a serial entrepreneur. So we put our heads together and design a ventilator. So we have put together a little breathing machine. We made it out of few components that we have sourced easily and inexpensively, and they are in abundant supply. We looked online for ventilator designs. We could not find any particularly usable design. And many designs show you how to build a pump out of a breathing balloon. But really, making a pump itself is the least of the problem here. There is much more that needed to be done to provide artificial or assisted breathing. You have to control the volume and pressure of air of every breath. You need to control breath frequency. You need to control temperature of the air, humidity, and you need to try to synchronize the pump's operation with the attempt breath of the patient. There are air pressure limitations that needs to be obeyed, otherwise you risk injuring lungs of the patient. And most importantly, when something goes wrong with the machine or some pressures go out of bounds, it's very important to sound an alarm. It was very important to design something that would be practically usable, that has a standard air outlet on this, and to have easy and familiar controls for the doctors. Here we have a touch screen. It is important to have many sensors on this device. Some of these sensors that we tried to obtain through traditional catalogs are already out of stock because precisely they're used in the breathing assistance machines. So we had to design, for instance, our very own flow sensor.
I programmed the EzLung. The EzLung runs on a conjunction of an Android tablet and an Arduino Uno. Here we have the user interface for the EzLung. On the left side, we have the alerts, which we have none of right now. On the top, we have graphs, illustrate all sorts of useful metrics. And on the bottom, we have our controls. Let's plug it in and see how it works. So here we can control our breaths per minute here, which increases the frequency of the patient's breath, and the tidal volume.
So we need some help. We need some help in completion of this device. We need help with funding, and most importantly, we need the help with FDA approval for this device.